let's continue with the second part of this chapter. We're still looking at the terminology. So the next terminology is insulator. Basically, insulator implies a low electrical conduction materials that basically do not allow electrical to conduct or electron to pass through. And we use insulator to indicate electrical obstruction. Insulator, we use it to obstruct, to isolate from any electric conductive material, conductive electrical material. Next is dielectric. So the term dielectric typically means materials with a high polarizability. So dielectric is also an insulator, but it is also we look at the dielectric as a material with high polarizability to indicate that the material has energy storing capacity by means of polarization. So in order to understand that, let's look at this figure here. So this figure shows the conductor, and in between the conductors we have insulator or dielectric materials, right? So the dielectric material has molecules. It has molecules, and the molecules consist of negative and positive charges. All right. So when the dielectric material is unpolarized, then the charges inside the electric materials is not aligned. It is basically everywhere. But when we apply electric field, for example, here we apply positive electric field on the top, negative electric field on the bottom, then the charges will align according to its opposite charges. So the negative charges will try to align, stay closer to the positive charges, and the positive charges of the electric material will align and try to stay close with the negative charges of the negative electrode. So when we have this electric field applied on that conductor between the insulator, then what happens is that this material is polarized. Okay, has been polarized. So next is permittivity, the measure of resistance that is encountered when forming an electric field in the medium. So we apply electric field, and then when we apply the electric field, the material, the molecules, the positive and negative charges in the molecules will try to align according to its negative and positive charges. And then how difficult it is for the molecules to align. Okay, some materials are easily to align, some materials are difficult to align, takes time to align, to polarize. So that difficulty or resistance when forming that polarization is called permittivity, right? So the SI unit of the permittivity is is epsilon, right? So epsilon of every dielectric materials are different. For example, air is 1. Okay, bakelite, cellulose, fiber, mica is different. They are different. So you can see here for air is 1, meaning that it is easy for the polarization to occur, right? Why? Because the molecules in the air is freely to move. okay, is in the air. But when we have molecules inside solid insulator, for example glass, which are very solid material, means that it is very difficult for the molecules to move around, to polarize. So that's why the permittivity is higher in solid material. So again, dielectric is also called electrical insulating materials, or in which electric field can remain almost indefinitely. The materials thus offer a very high resistance to the passage of direct current. So basically, dielectric materials or insulation materials, it try to resist or avoid from the electric current to flow inside the insulation materials, right? And it says here, can be formed as gas, solid or liquid. So the purpose of dielectric materials, we use dielectric materials in high voltage engineering, in high voltage application, basically to control the flow of current between two conductors. Not just to control the flow, but basically to block, all right, to avoid, to block completely flow of currents. In the context of engineering applications, dielectrics can be found from everywhere, all right, in many applications: power cables, insulation, cable insulation, printed circuit board. This is for low voltage application. Transformer, using oil as insulation, paper as insulation, right? So many applications. The desired features of the electric materials are often very similar. However, the non-electrical properties required often dominate the choice of materials. All right, what does it mean, non-electrical properties required? We have selection of gas or solid or liquid insulation or dielectric materials to use from, but which one is the best depends on the application, right? Such as in circuit breaker, we use gas is the best insulation. In power transformer, we use both liquid and oil, and also there are power transformer which only use solid, all right. Insulator core use polymer composites, silicon rubber for insulator sheds, and etc., right? So this is an example of underground cable. So in underground cable, we use material called XLPE as insulator. So XLPE is solid insulation. However, it is because of XLPE is slightly flexible, so it is good for the application in underground cable, because we do need to bend a bit the conductor or the cable. So we use XLPE or cross-linked polyethylene material, it's called, for underground cable. Next, we have air circuit breaker. Circuit breaker is pretty much like a switch, all right? So of course the switch, we have main contact, we have fixed contact, right? When we turn off the switch or turn off the circuit breaker, then what happens is that there will be an electric arc, okay? Electric arc produced because we are opening the switch. Then because of this, we need to have this arc appear in the air, okay? Because if we have electric arc in XLPE, in solid material, then it will damage the solid material. So in this case, for this application, for circuit breaker, it is better to use gas or S, okay, gas as solid, gas as insulation material. Another example is transformer. So here in transformer, we use both oil or liquid and paper insulation. So you can see here in the picture here, so this is oil used for insulation. And
in database systems, isolation determines how transaction.
So oil is used for insulation and also for heat dissipation. All right, quite similar to personal computer nowadays. There are certain computers that is we use oil to dissipate the heat. Okay, we create the PC, we create the PC, we assemble the PC, and inside the PC we put on oil because we want to dissipate the heat. But the oil is a good insulation, so it will not conduct electricity. So elements of dielectric. Dielectric plays an important role in separating the electrical potential objects with the earth object. Okay, we want to separate the components or object that conductor that is carrying high voltage, and then conductor which is grounded 0 volt. And then we use as medium in insulating the electrodes: paper insulating winding transformer, XLPE in cable, so on. So lower thermal conductivity in the electrics is used in preventing breakdown. Okay, so if we have insulation and at the same time it has good thermal conductivity, meaning that's good for dissipating heat, then we can use it for as cooling as well. Okay, not just for insulation, for electric insulation, but as cooling as well. And then high dielectric strength material is used as medium inside the circuit breaker. So circuit breaker, we use air, but if we want to go for higher voltage, for 33 kV, for 132 kV, 500 kV, so we cannot use air as insulation in circuit breaker, because air is usually used until, I would say, 415. Not sure if we have 11 kV as circuit breaker. Yep. Right. So for higher voltages, we usually use SF6. Characteristic in dielectric. So dielectric materials, and its characteristic that we need to look for is the chemical stability. Okay, we need to make sure that the dielectric material that we choose has good chemical stability, and good thermal conductivity, because of in transformer we want to cool down the conductor carrying high current, so it will create a lot of heat, so we need to dissipate the heat. So we have to look for the electric material that has good thermal conductivity, and then we have to look for dielectric material that have good mechanical strength, because we need to use it for example in the HV insulator, where we use this in overhead line. So the insulator must be able to carry very large cable, okay, in overhead line. And then processability, cost, of course, need to look at the price as well. Low smoke emissions, thermal resilience, low density, and so on. So many characteristics that we need to look for based on the application that we are going to use it. Then maybe we can go quickly in this video. So here you can see an electric arc. So in this open substation, you can see it's open the switch, and then because of that it produces electric arc. okay, produce electric arc. So this is in open, in the open. However, when we have circuit breaker, we quickly, so here when we open the circuit breaker, then the arc will appear like that, but that is why we need to have the splitter to split up the arc, and then it will distinguish the arc. Then another one, disconnecting switching.
Фаза С, отключай! Отключена!
Okay, skip. So almost finished there. So problems with dielectrics. What are the problems that we have in with the dielectrics? For the purpose of discussing the flow of current, all substances may be placed in one of two categories. So, insulator and conductor. Insulator, basically impossible to cause any current to flow. So that is the purpose of insulator, to block any current from flow. So in this case, the problem with the insulator or the dielectric is when all negative charge are firmly attached to their sorry, let me repeat that again. In this case, all negative charges are firmly attached to their corresponding positive charge, right? So this is when the insulator or dielectric metal in normal condition. Remember the polarization image. So when there's no electric field, then all negative charge and attached to the corresponding positive charge, so it stays in stable condition. So no net flow of charges take place in insulator. And then conductor is a substance or material in which certain number of electrons can be easily made free from their associated positive charge. Means that conductor has also positive and negative charges inside it, but the negative charge or the electrons is easily can be made easily to flow in the conductor, so it can carry current, right? And made to move under influence of electric potential difference. If we have electric potential difference, then we can make the current to flow. However, under certain conditions, free electrons and positive charges can also be made available in an insulating materials. So it is also possible that in certain conditions, free electrons, okay, inside insulating materials, and then when the electrons flow, then it will behave like conductor, meaning that the current will start flowing. So when the current to start flowing, then this is called the breakdown of insulator. So you can see here, initially in typical normal dielectric materials, we have negative and positive charges, and then we apply electric field, then the materials are polarized, all right, and then when we apply voltage, much higher voltage, and then the electron starts to flow, right, start to flow until it reach to the other side of electron. Then this is when we call the current has complete the flow, mean that it has breakdown, the insulation has breakdown, means that it start to behave like a conductor. So this is the main problem with the electric materials that we have to look for, we have to study, we have to investigate in order to avoid this from happening. So the breakdown process of the material may be influenced by mechanisms such as chemistry, physics bonding, electric field, stress, temperature as well. So there is no perfect insulator or even no perfect conductor. Each of the material has its own electric withstand. Okay, glass, oil, paper has air. They have their own electrical withstand value, the electric strength, right? So if you go back to the previous slide, as you can see here, breakdown strength, air is 30 kV per centimeter. Paper is much better because paper is solid material, so the breakdown strength or dielectric strength is 200 kV per centimeter. And then if you can see here, glass is 1000 kilovolt per centimeter. So different materials has different dielectric strengths.